patterns here, patterns everywhere. There are plenty of patterns that we can observe. So, you might be wondering, what is the study of patterns? Yes, you're right. It's mathematics. Patterns may be numerical, logical, and geometric. Geometric patterns look nice because of symmetry. A pattern has symmetry if there is an isometry of the plane that preserves the pattern. So first, we'll discuss about transformation. Transformation is a process which shifts points of the plane to possibly new locations in the plane. We focus on the following transformations: translation, reflection, rotation, and dilation. Translation, or a slide, moves a shape in a given direction by sliding it up, down, sideways, or diagonally. In this example, the triangle has been translated. The triangle, called the image, has been moved to the right. A translation always moves an object, but it does not turn it, flip it, or change its size. Reflection. Reflection or a flip can be thought of as getting a mirror image. In this example, the triangle on the right has been reflected or flipped over the dotted line, which is called the line of reflection or mirror line to create a mirror image. Reflection can also be seen in this drawing. The boat is being reflected in the water. Rotation. Rotation or turn has a point about which rotation is made and an angle that says how far to rotate. The rotation is completely determined by its center P and angle of rotation theta. In this example, the coin is being rotated based on where it was landed. Dilation. Dilation is a transformation which changes the size of an object. This is different from the other three transformations which somehow preserves the object. For example, it's Anna's picture day. Anna can choose the package with one large photo for her parents, a larger one for her grandparents, and smaller ones for her friends. Through dilation, the picture stretches or shrinks. Transformations which leave the dimensions of the object and its image unchanged are called rigid transformations or asymmetric transformation or isometries. Examples of this are translation, reflection, and rotation. On the other hand, transformations which change the dimension of the object when they act on it are called non-isometric transformations. Example of this is dilation. However, if you perform a reflection followed by a translation or a translation followed by a reflection, you get an isometry different from any of the previous types. This is called a glide reflection. Example of this is the walking footsteps. Art and mathematics intersect in the concept of symmetry. Symmetry means that one shape comes exactly like another when you move it in some way, turn, flip, or slide. In mathematics, symmetry can be defined and verified by finding motions that leave a design unchanged. These motions can be combined and analyzed in much the same way numbers are. There are three types of symmetric patterns: rosette patterns, frieze patterns, and multiple patterns. In this presentation, we'll talk about frieze patterns only. Frieze patterns are basically patterns that can be mapped onto themselves with one or more transformations. They extend both left and right on a line. The transformations used with frieze patterns are generally one or more of the following. We have translation, rotation, and reflection. These transformations can be combined to other symmetries as well. Each possible combination of symmetries is called a frieze group. It turns out that there are 7 different unique frieze groups, and mathematician John Conway created names that relate to footsteps for each of the frieze group. The first frieze group contains only translation symmetries. According to Conway, this is called the hop. For example, this is a mosaic border in Alcázar de los Reyes Cristianos in Cordoba, Spain. It shows how the waves are being translated indefinitely. The second frieze group contains translation and rotation by half-turn symmetries. Conway named this as a spinning hop. For example, this is a Miller frieze in a Chinese vase. It translated indefinitely and the object has a rotation of 180 degrees. The third frieze group contains translation and horizontal reflection symmetries, and is called a jump. For example, this is a Kiswa stand from the Ming Dynasty, we can clearly see that the transformations in this pattern are translation and reflection across a horizontal mirror. The fourth frieze group contains translation and vertical reflection symmetries and is called a sidle. For example, this is a tile frieze in Palacio de Velázquez. It really has a vertical reflection since it reflects the left to right side. The fifth frieze group contains translation and glide reflection symmetries, and this is called a step. For example, this picture shows a pattern from a Navajo rug. We can see that the triangles are translated. The top triangles and bottom triangles are not lined up, and so there is a glide reflection. The sixth frieze group contains all symmetries such as translation, horizontal and vertical reflection, and rotational symmetry, and this is called a spinning jump. For example, this pattern is a ceramic design from the San Ildefonso Pueblo. Finally, the frieze group contains translation, glide reflection, and rotation by half-turn symmetries. According to Conway, this is named a spinning sidle. For example, this is a lienzo bowl with underglazed blue decoration. So basically, an easy way to think about frieze patterns is to think about borders. And this could be borders on paper, wallpaper, on tiles, on clothing, on rugs, designs on pottery, indigenous art, needlepoint stitches, ironwork, railings, any architecture that you might see, or just like any decorative art that you can imagine. So, who cares about frieze patterns, huh? Well, aside from the fact that it can be used for wallpaper patterns, frieze patterns allow us to create and appreciate many art forms in our everyday life, like those I mentioned earlier. Also, creating them and understanding them can help improve our spatial intelligence. Isn't it amazing? So, that's for today. If you have any questions about anything in this video, just let me know.